The HT loop and the LTA loop in the cooling system are filled through the respective fill lines. These lines carry coolant from the makeup tanks to their respective pump inlets. This purges air from the system by filling the engine from the bottom up. Air is purged from the cooling system through vent lines that connect to the top of the aftercooler. In the HT loop, coolant is drawn into the water pump inlet by the gear-driven water pump mounted at the lower right side of the gear housing. The water pump impeller draws coolant into the water pump housing and supplies coolant flow to the engine via the splitter box. Part of the output from the HT water pump empties into the center cavity in the V of the engine block. As this coolant flows to the rear of the engine, it surrounds the oil cooler cores. This provides the oil coolers with the lowest possible temperature coolant. As the coolant in this cavity passes around the oil cooler cores, heat is transferred from the oil to the coolant. The coolant flows to the coolant dam at the rear of the engine, where the flow splits and flows back toward the front of the engine through the two outboard passages in the V of the engine. As the coolant flows through these outer block cavities, it passes through small cast openings in the block. From these openings, coolant enters the water jacket area of the block. In the water jacket, coolant travels around the liners, removing combustion heat. Coolant passages in the top of the block allow the coolant to flow out of the block and through the cylinder head. After leaving the cylinder heads, the coolant flows up through the passages in the rocker housings to the water manifold. The coolant then flows toward the front of the engine through the water manifolds into the thermostat housing. Coolant in the thermostat housing circulates around the sensing bulbs of the 6 high-temperature engine thermostats. When the coolant at the engine thermostats is below the thermostat modulating range, the thermostats are closed, allowing the coolant to flow through the center of the thermostats. The coolant then flows out the bypass connection on the right end of the housing. The coolant passes through the bypass line and back to the inlet of the water pump. When the engine operating temperature increases, the thermostats start to open, restricting the bypass passage in the thermostat housing. When the bypass passage is blocked off, the coolant flow is fully directed to the radiator. To ensure a positive pressure head on the water pump, the fill line supplies coolant directly to the inlet of the water pump. Approximately 10% of the high-temperature coolant flows through the 2 coolant filters. From the coolant filters, coolant returns to the bypass passage that leads to the inlet side of the water pump. The higher pressure coolant from the thermostat housing causes the coolant to flow through the filters and into the lower pressure bypass passage. QSK gas engines are equipped with a 2-stage aftercooler for the intake air system. Coolant from a second outlet on the splitter box flows through the external piping to the aftercooler mounted on the front of the engine. In the aftercooler, the coolant circulates through the tubes in the first section of the core to lower the temperature of the air-fuel mixture from the turbocharger compressors. From the aftercooler, the coolant flows out of the right rear fitting through external piping to the coolant dam at the rear of the engine block. Here it joins the coolant from the oil coolers and travels through the engine to provide cooling for the liners and other engine components. QSK gas engines have water-cooled turbochargers mounted to the exhaust manifolds. Coolant from the HT aftercooler supply pipe flows to the bottom fitting in each of the turbocharger bearing housings. Coolant travels up through the bearing housings, cooling the turbochargers. From the top fitting in the turbochargers, the coolant returns to the top of the aftercooler. The pressure differential between the pump outlet pipe and the aftercooler causes the coolant to flow through the turbocharger. In the LTA loop, coolant is drawn through the water inlet by the gear-driven LTA water pump mounted on the lower front left side of the gear cover. From the LTA water pump, the coolant travels through a supply tube to the lower connection on the left side of the aftercooler. In the aftercooler, the coolant circulates through the tubes in the second stage of the core to further reduce the temperature of the intake air from the turbochargers. A coolant return pipe connected to the bottom left side of the aftercooler directs the flow of coolant to the LTA section of the thermostat housing. In this part of the housing, the LTA coolant flow circulates around the temperature sensing bulb of the LTA thermostat. When the coolant at the thermostat is below the thermostat modulating range, the thermostat is closed, allowing the coolant to flow through the center of the thermostat. The coolant then flows to the front of the housing and back out the bypass connection to the inlet of the LTA water pump. When the coolant temperature increases, the thermostat starts to open, restricting the bypass passage in the LTA thermostat housing. When the bypass passage is blocked off, all of the coolant flow is fully directed to the LTA radiator. Coolant returns from the LTA radiator back to the inlet of the LTA water pump to complete the circuit. To ensure a positive pressure head on the LTA water pump, the fill line supplies coolant directly to the inlet.